Welcome back, engineers. In this video, we're going to do a deep dive into circuits and explore an important concept, polarity. You already know how to build circuits with a variety of components, but now we're going to learn why the direction of electricity matters in some components, but not all. By the end of this video, you'll be able to define polarity and understand its importance, evaluate circuit diagrams for polarity errors, and understand and apply norms when constructing electrical circuits. While building our first circuits from diagrams, you may remember having to make some changes to the circuits to make them work. Some components would only allow electricity to flow one direction. Like me, maybe you needed to turn the block around so electricity would flow through it and complete the circuit. We describe that as unidirectional, meaning the current can only go one direction through the component. Polarity in electronics refers to the components having a relative positive and negative side. Batteries have polarity because the abundance of electrons on the negative side creates a negative charge when compared to the positive side. The part of the circuit that's connected to the negative terminal of the battery is called ground, sometimes abbreviated as GND. On circuit diagrams, ground will have a symbol that looks like this. To help when building and repairing circuits, the ground wires in DC circuits are commonly black in color. This is normally the case, but because electricity can be very dangerous, it's always important to reference the diagram to be safe and prevent damage or injury. In circuit diagrams, polarity is shown by the electrical symbols. For example, an LED symbol has an arrow showing you the direction the current can flow. A battery always has a plus and minus side indicated by the long and short signs in its symbol. Following these norms helps everyone to understand the correct way to build the circuit. Here are two circuit diagrams. One is a correct diagram of an LED circuit, and one has the LED reversed. It won't work if we hook it up. Using your knowledge of circuit diagrams, can you tell just by looking at them which one will work? Let's go ahead and build the circuits and check our answer. Were you correct? If you guessed the one on the right side, then yes, you were. The LED is pointing in the right direction, which means the current can flow through and the LED is going to light up. Many things can happen if current flows the wrong way. In the case of an LED in the SparkBlocks system, it just doesn't turn on. But with other components or higher power systems, the component or device can be damaged or cause a fire or even personal injury. To protect against the wrong flow, engineers use a component called a diode. We've already learned about one type of diode, the LED, but there are other types as well. Most of them don't emit light, but all diodes have the same feature. They only let current flow one direction. The electrical symbol for a diode has an arrow letting you know which direction the current can flow. Now let's try out a new component, the motor. In a future lesson, we'll learn all about motors and how they work. For now, what we need to know is that motors convert electric current into rotational kinetic energy. The symbol for a motor is a circle with an M inside. This circuit diagram has a motor symbol in it. Let's build this circuit together. We'll need a battery, a motor, and two wires. Let's not forget, we just learned that the negative side needs to be a black wire, so let's make sure to use a black wire for that and then a red for the positive side. Now that we've got our components, let's put the circuit together. On top of the battery, I'm going to set the black wire block on the negative side and the red wire block on the positive side. The motor's going to spin pretty quickly, so I'm going to add a fan to it to help us see which direction it's spinning. With the fan blade on, I can see that the motor's spinning clockwise. But what if we want to spin it the other direction? What's something that we could do? Go ahead and pause the video and see if you can figure out how to get the motor to spin counterclockwise instead. To get the motor to spin the opposite direction, we need the current to flow the opposite direction. But the current can only flow one direction out of a battery. By turning the motor around, though, we can connect the other terminal to positive, which sends the current the other way. That will then make the motor spin counterclockwise. Because the motor works in both directions, we call it bidirectional, meaning it works with current flowing two different directions. In the case of a motor, a change in the current direction will change the direction it spins. Can you think of a way that this might be useful? Let's examine all the spark blocks in our kit. On the face of the block, we can see the symbols for the components inside. Which diagrams make you think that a block is going to be unidirectional? Seeing symbols such as arrows, plus and minus signs, and GND can give an indication that current needs to enter one side and exit the other, making it a unidirectional component. Great work, engineers! Let's check our learning against our goals. We defined polarity and explained why it's important to understand when building circuits. We developed and used strategies to find errors in circuit diagrams when using unidirectional components, and we learned and applied electrical norms for when building circuits. So now you know how polarity affects circuits. Next time you see your LED not lighting up, don't panic. It might just be flipped the wrong way. Ready for another challenge? Design and draw your own circuit diagram that has a unidirectional component in it. Make sure your component's facing the right direction to allow current to flow. When you're finished, trade with a partner and check their diagram for errors.